this section, we're going to focus on allocating RAID partitions, namely RAID 1 and 5, using command line tools while the system's up and running. So let's label this section RAID, or redundant array of inexpensive disks. And the features include the ability to increase the availability and reliability of data using various methods. Now, Red Hat Enterprise implements RAID via the kernel. It implements multiple versions of RAID. 0, 1, 5 are the most popular, and the redundant versions include RAID 1 and 5, which is why we'll spend our time there. So let's label our subsection tasks to include create a RAID 1 device. RAID devices are represented beneath the dev tree as follows: dev MD0 through N. The first dev RAID device will be labeled MD0, the second 1, the third 2, and so on. Now, there's a command that's used to create RAID devices as well as to manage RAID devices named mdadmin. It's included and it's installed by default. Using this tool, we can construct enough statements to create a device such as dev MD0 on our remote system. We also need to set the level of the RAID, equivalent to 1 for mirroring, and then indicate the RAID devices that are to be included. Since it's a RAID 1 device, it requires at least 2 distinct partitions, such as dev SDB1, dev SDB2, and then you must indicate the actual devices, such as dev SD, and we'll indicate a question mark, or SDB question mark, because we've yet to create the partitions. So to create a device, we're going to use the mdadmin command. But before we can actually use the mdadmin command, we need partitions. So step A will be to use fdisk on the dev SDB disk to create usable partitions. We don't need to overlay the partitions with file systems, but we do need to create partitions, raw partitions. So use to create usable raw partitions, which the mdadmin utility will make into RAID or software RAID partitions. So let's connect to our remote system, RedXCBT Serve 4, using its IP address. And once on the remote system, we'll execute fdisk-list to enumerate the drives that are connected to the system. And here we hit our own IP, which is why the public key came back. It's 75.199 as opposed to 10. That's more like it. And this should come back momentarily. And we'll authenticate. And now we're on. So with that said, we'll fdisk again -L, where we'll see that there are 2 drives connected to the system. We won't use SDA because it's loaded with partitions with very little free space between the cylinders 993 or between the range of 993 and 1044, the cap. So we'll focus on SDB. You can create RAID partitions out of a single disk or multiple disks. The ideal scenario is to use multiple disks as you spread your data across those disks, consequently increasing reliability, performance, and availability. Let's just note that you may create RAID volumes /devices on a single or on multiple disks. Ideally, the RAID volume or volumes should span multiple physical disks to improve reliability, performance, and availability. So with that said, let's create the partitions. So our first step is fdisk SDB. We'll then need to create partitions of equal sizes since we're going to create a RAID 1 volume. Once in, we'll print the partition table and then create new partitions. Now we have the option of creating two primary partitions at positions 3 and 4, or creating a logical partition now, or creating multiple logical partitions in an extended partition. We'll use new to create a new partition and indicate that it's extended. Number 4, from the next available cylinder, 563, which is immediately after 562, to the end of the disk, which is located at cylinder 1305. When we reprint the partition table, we'll see that we now have an extended partition which ranges from the first free cylinder to the last. With that said, we can create n number of logical partitions. Beginning at 563, we'll make this partition 2 Gs or 2 gigabytes. Print the table, we now have an SDB5, which is 2 gigabytes ranging from cylinders 563 to 806. So let's create another one. It too will be logical. We're prompted with the option to create a primary partition because there is still space for primary partitions. In this case, SDB3. So 807 will be the start cylinder, and we'll make it also 2 gigabytes in size, and we'll print the table. So now we've got two Linux Type 83 2 gigabyte partitions with room to spare for subsequent partitions. We'll save the changes using W to write the changes to the partition table. And because the system's up and running, the kernel still uses the old partition table. So with that said, we've used fdisk, and we'll then use partprobe against devsdb to force a kernel update of the partition layout on the disk. And by the disk we mean devsdb. Let's copy and paste this command and give it a shot. And we'll echo the exit status, which we missed the variable, but nonetheless partprobe ran successfully. We may try it again, and there's the exit status. So now that this is in place, we can execute the mdadmin command to create the dev device. And we're going to do so using the partitions. Let's update our command using fdisk list. We're going to do so using the partitions SDB 5 and 6. So we'll update our command as follows. Let's give this a try. So again, mdadmin create the first RAID device as MD0, but we could indicate any number. It's our prerogative. The level of RAID, 0, 1, 5, or whatever is supported, just man mdadmin, and you'll find out the levels that are supported, but the common ones include 0, 1, and 5. Indicate the number of RAID devices that are to be made members of the RAID set, and then one by one list the devices as they exist in the dev tree. And here we see that the file system appears to have ext2fs. It wants to know if we should continue. We'll indicate yes. And the process has started. Now, just like in Windows, if you use, let's say, a Dell or HP or IBM tool to create RAID, the process doesn't happen immediately. And as a result, there's a way for us to check on the status or the progress of the kernel. If we cat the contents of proc mdstat, we'll see exactly what the kernel is doing. We'll see where it stands with respect to creating our RAID volume. So mdstat lists active RAID information. It lists the MD devices, and it lists status information. Let's cat the contents, and we'll see that it's currently at 31.2% of the process. And it's moving pretty quickly, 5% increments. And if you want to see this in as close to real time as possible, this is an opportunity to use the watch command followed by cat proc mdstat. And you'll see the percentages increase as the process unfolds. So, with that said, we have our little ASCII art going here with the arrow, which indicates how far into the process the kernel is in creating the RAID volume devmd0, which will lead us to the documentation of our next step. Once it's at 100%, we need to overlay a file system. So make 2FS with journaling turned on devmd0 overlays a file system on the RAID device. And once that's done, we can mount the file system. So then we'll mount devmd0 at a directory that we've yet to create. We'll call it RAID1 to indicate that it's a RAID1 device. And for the sake of having this volume available when the system reboots, we'll modify etcfs tab. So update the file system table file with an entry for the RAID device to be sure that it comes up. And again, it's of type ext3, so it'll take any option that applies to an ext2 file system for the most part. So this is almost complete. And again, we need to create that RAID1 mount point. So this is finished, and we'll make a directory at the root named RAID1. Then, as we've mentioned, we'll overlay a file system. Now, you can determine the status of a RAID device without a file system using mdadmin. Let's just note that. Use mdadmin query and the name of the device. In this case, it's devmd0 to get information about a RAID device. Let's go ahead and copy this and try it from the shell before we overlay the file system. And if the device is not a device, a RAID device, then mdadmin will return an error. But here we see that we have roughly 2 gigabytes configured for RAID1 using 2 devices with no spares. mdadmin, if you execute it with the help option, has a whole load of help and many modes in which you may execute it, including monitor, report, create, which we've used, as well as manage to make changes to a device, which we'll show you momentarily when we stop the MD0 device. But again, a simple query of the device will return the configuration of the device. Let's try it for a device that doesn't exist, for another one, and so on. So with that said, let's move on to the next step, and that is to overlay the ext3 file system. Now again, we've been using exclusively ext3, ext2, but there is nothing holding us to ext2 or 3. We could use any supported file system, XFS, JFS, RiserFS. It's up to you and whatever you have standardized on in your environment. So let's give this a try to create the file system. It's only 2 gigabytes, so it should take very little time. And once this is in place, we'll be able to mount it. And that's fine. Exit status is clean. We'll then mount devmd0 at RAID1. And once it's completed, a mount will tell us that it's available. A df-h will also confirm that it's available. And an lsltr of dev, or in this case RAID1, will reveal the lost and found entry, and we can use sequence, let's say 1 million, to write something to RAID1 just to test it. And there it's writing to the multiple partitions. But again, there is no real speed benefit when using one disk to represent a RAID array. Super. So we've got a file now on RAID1, and we've covered how to set up a RAID1 device when the system is up and running, because again, it is a test requirement and you need to know it for production environments, because Linux systems tend to be very stable, and in your environment you may have it up and running without much flexibility by way of being able to bring the system down. And if that's your scenario, as is my scenario and many Linux administrators' scenarios, then you'll have to know how to effect changes with the system up and running without disrupting connections. So our RAID 1 device exists, so we should walk through the creation of RAID 5. So our next task is to remove the RAID 1 device. Although we haven't updated ETCFS tab to reflect the changes, and to do so, we'd simply narrow ETCFS tab, and towards the bottom just include an entry, RAID volume, and a pointer to the device, followed by its mount point, which is /, and you can see above from other entries, device followed by, and we'll scroll down here, mount point, which is RAID 1, and the options are up top for the type ext3 followed by defaults, followed by the order in which the devices are to be scanned, if ever, when being booted. This is enough to get the RAID volume up and running. Now with that said, let's move on to the next task, which is to remove the RAID 1 device. So first and foremost, we'll unmount the device, either using umount dev MD0 or umount RAID 1, the actual mount point. And we should ensure that we're not in the directory. We'll confirm that it's been unmounted. It doesn't appear anywhere in here. And with that said, we will remove the device using the next step, which is mdadmin manage stop and the name of the device. Once we've completed this step, we can move forward with the RAID 5 configuration. As we can see, the device has been stopped, and now we may move forward. So task 3 is to create a RAID 5 volume. And the steps are straightforward. mdadmin, create devmd0. The level is 5 instead of 1. The number of RAID devices is the minimum, 3. And the devices will be dev sd, the list that we've created for the creation of the other device, 5, 6, and we'll include a new device, 7. But there is no SDB7, so again, as usual, let's move this to step B and indicate that we'll use fdisk followed by the name of the drive, dev sdb, to create a partition number 7. So let's go ahead and execute that. Here's the table, new device, logical, the vault starting, and it'll be 2 gigabytes. Print the changes, and as you can see, we're almost at the edge of the hard drive. There's very little space remaining, but enough to do what we need to do. We're writing the changes, or attempting to write the changes, and of course we'll need to use part probe, which we can get from our command history, and then execute echo $, which should return accordingly. So fdisk, and let's just include as step B, part probe, dev sdb, to update the kernel's view of the partition table on the disk. Now we can execute the creation of the RAID device dev md0, or at least attempt to create dev md0 using mdadmin. And it sees the disks. It'll determine whether or not there are partitions or file systems allocated. So with that said, we're back to catting procmdstat to get a sense for its percentage, its progress. And again, we could use watch, which will refresh every 2 seconds as indicated in the upper left-hand corner. And it will just continue to update us as the RAID 5 volume using 64K chunks is created. Now while this gets created, again, let's just recap the simple process of creating RAID volumes. Ensure that you have enough partitions, preferably spanned across multiple disks, but it will work within one disk, although you should not see any performance improvements by operating on one disk or creating a RAID volume on one disk. So ensure that you have enough partitions. For RAID 5 you need at least 3. For RAID 1 you need at least 2. Update your partition table using fdisk. Update the kernel's view of the partition table using partprobe. Once all is set, you can confirm, of course, using fdisk-l followed by the device identifier. Use mdadmin to create the device, indicating the level, indicating the number of RAID devices, and enumerating the devices that are to be made members of the RAID set. Then you cat the contents of the mdstat file because it tells you what the kernel is doing. Cat proc mdstat, and you may optionally execute it with watch. This will refresh, so refreshes by default every 2 seconds. The execution of cat proc mdstat. Once the process has completed, and right now it's almost at 70%, you then overlay a file system. So step E is to overlay a file system. Since we've been using make2fs or ext2 file systems, we'll again just reference make2fs, turning on journaling using the lowercase j option followed by the full path to the RAID device, which is located beneath the dev tree as dev md0. Once this process has completed, mount the drive or mount the RAID device. Dev md0 at, let's say, /RAID 5. If all looks well, and you can tell, so test IO to RAID device. If all looks well, update etcfs tab so that when your system reboots, the device is made available. Now while this partition gets created, and it seems to be finished, let's make directory /RAID 5, and then move on to the next step, which is to overlay the file system using make2fs, and it'll be in our history, so no need to copy it. We'll just use shebang make2, and this will execute the creation of it. We can always query the RAID volume using mdadmin with the query option. Again, mdadmin supports many other options: management, allocation, the ability to shrink, to grow, to add spare disks or partitions to the RAID sets, you name it. mdadmin query dev md0 describes the RAID partition. In this case, it's 2/3 or 2 of the 3, equivalent to 2 of the 3 partitions included. Roughly 4 gigabytes of 6 gigabytes, or 2/3, 4 of 6. So here it is, it's available, it's RAID 5, and now that we have a file system on it, we're free to mount it. Let's mount dev md0 at RAID 5, echo the exit status, execute mount, and then grep md0, and there it is. That's LSL, RAID 5, sequence 1 million, RAID 5, test.raid5.txt. This will be created momentarily, and we'll ls it again just to be sure that it's there, and indeed it is. So the last step is to update fs tab to include dev md0 at RAID 5 as type ext3 with defaults and 00 for the checks. The ext2 checks when the system comes up. If you wanted to check it, then set the order similar to the other ext3 file systems using 1, 2, just to be consistent. So that's how you set up RAID volumes once the system's up and running. Remember, when your system is being installed, you have an excellent opportunity using DiskDruid, the GUI interface, or its text counterpart, to create RAID as well as LVM partitions, as well as devices. But if you find yourself with a running system and the need to create a RAID volume, whether 501, then you'll need to use mdadmin. after, of course, having created enough well partitions to support your RAID volume. So that's really all there is to laying out RAID. It's very straightforward. The tools are streamlined. No big deal whatsoever.